Hello, Year 10. Welcome to Term 2. I know things look a little bit different, but this should still be fairly straightforward from what we're moving on from last term. We're looking at chemical reactions. You'll have access to some workbooks, so I'd advise you to look through your workbooks as we go through this. The answers to the questions will all be throughout these lessons, and also you can find us on Zoom. So if you're able to access Zoom, then log in at the appropriate time and we can discuss any questions you have or go over this in a little bit more detail too. Cool. So this year we're looking at chemical reactions, but before we do that, we need to recap what we did in Term 1. So all of Term 1 we were talking about the universe after the Big Bang, the creation of stars and galaxies and things like that. So it's important because we're following on directly from that. The information we learned last term is really important. We're building upon that this term. We were talking about chemistry. So just a quick reminder, we looked at the Big Bang. You remember all the way from the very beginning, the first few seconds, we talked about protons, neutrons, electrons, atoms, plasma universes, Doppler effects. We'd covered a ton of information and you guys smashed it out of the park. We went through so many topic areas and we had some great discussions. So I'm hoping this term is no different. Even though we're online, we can still discuss things via Zoom. So just to remind us, what is going to be important for this term is talking about atoms. And just to remind us what the structure of an atom is, this little GIF shows us something that is what we believe is the closest representation we have of an atom. And you can see here there's the nucleus, where we have the green, which I'm presuming is protons, the blue are neutrons, and the little yellow particles flying around the nucleus, orbiting the nucleus, are called electrons. So if you count these ones, hopefully remember we have 3 protons and 3 neutrons, 3 electrons, it must be lithium. So lithium has 3 protons, that makes lithium. So we're going to be talking about that quite a lot this term and applying that knowledge a little bit more in terms of how did the electron arrangement affect a chemical's reactivity. So I'm just going to read through this very, very quickly, but just to remind ourselves, the electrons are about 1/2000th of the size of a proton or a neutron, so they're a lot smaller than the neutrons and protons in the nucleus. Electrons have an electrical charge of a -1, so we know they're negatively charged. Remember last year I said that electrons are, the way to remember it would be if we were paying our electricity bill, it's a negative experience. Electrons are negatively charged. An atom has the same number of electrons as protons. The charges balance out, so no atom has an electrical charge. It is said to be neutral. So that's important. So remember we say there's the same amount of protons as there are electrons. So the atom itself is not charged because say you have 3 electrons in the case of lithium and 3 protons. Remember the protons are positively charged. So if you have 3 positives, 3 negatives, they cancel each other out. A neutron has no electrical charge, so that doesn't affect the charge. And protons and neutrons make up the nucleus. They're held together by a very strong nuclear force, which is one of our 4 fundamental forces, if you remember. SWEG, we had strong nuclear force, weak nuclear force, electromagnetism and gravity. So strong nuclear force is one of the 4 fundamental forces we discussed last term. Protons and neutrons are also the same size. A proton has an electrical charge of +1. The number of protons in an atom determines what type of atom it is. Now that's important. For example, every atom with 79 protons is a gold atom, and every gold atom has 79 protons. Substances that are made up of only one type of atom are called elements. So we're going to be discussing this in more detail, so don't worry too much if this is a little bit overwhelming. There's a lot of information. But essentially the key message here is the number of protons in an atom determines what element it is. So if you remember last term we were talking about hydrogen, which has 1 proton, and if a hydrogen with 1 proton fuses its nucleus through nuclear fusion with another hydrogen which has 1, then it has 2 protons. It's no longer hydrogen anymore, it forms to create helium. So the number of protons dictates what element you have. Electrons move rapidly around the nucleus. Although they follow no set paths, electrons are always found in regions called electron shells. Now we discussed this a little bit last term as well. So remember when we drew our electrons, we would always have 2 in the first electron shell and then we could have a maximum of 8 in the second electron shell. We're going to be looking at that in more detail. They're actually really important. The number of electrons in these electron shells is related to how reactive or unreactive a chemical element is. So again, just to reiterate, that's the structure of the atom there, so we know what that looks like. Okay, so we've just basically spoken about that at length here in a little bit more detail. Okay, in your workbooks, what I'd like you to do is maybe pause this video, and I want you, based on the information we just discussed, to think back to term 1 and see if you can label the components of the atom. I'll go over the answers fairly quickly here, so if you pause the video now and have an attempt. So where you see A, we'll start with A together. It looks like it's orbiting around the nucleus. It has a negative charge. Hopefully, everyone knows that is an electron. So A is electron. Okay, so pause the video and try the other ones yourself. Okay, if you've attempted these, if you look at B, B is pointing to that inner area of the atom. And I've spoken about that where all the protons and neutrons are. Collectively, we call that the nucleus. C is pointing to the nucleus, but it's pointing specifically to the particle with a positive charge. Protons have a positive charge, P and P. So hopefully you got proton for C. D is pointing to the inner and outer rings where the electrons are. So we just discussed that they have a special name, and that name is the electron shell. So the electron shells are where we find all the electrons sitting. You can see from this diagram that we have 2 in the inner electron shell, and there's 2, 4, 6 in the outer electron shell. So if you counted all this up, then you should be able to know, if you look at a periodic table, we have 8 protons, 8 neutrons, and 8 electrons. We have oxygen. And if we look at E, E is the final part that we've not discussed. It's also in the nucleus beside the protons, but it has no charge that we can see. That is a neutron. So hopefully that's not all brand new information, just a little bit rusty perhaps over the break, that's okay, but this is what we're going to be looking at quite extensively this term. So if you know the fundamental structure of an atom, then we're doing well. So remember, protons are positive, neutrons, that shouldn't say neutrons, neutron is neutral, and electrons are negative. So we looked at the periodic table a little bit last term as well, because it was really useful for us to understand why is the periodic table arranged the way it is. And we realised that if you know the number of protons of an element, then that's the number it is in the periodic table. So for example, the number 1 is hydrogen, has 1 proton. We just looked at oxygen, which is number 8, has 8 protons. We talked about gold, which had... Where was gold? Here. Okay, gold down here, 79. So at high school, nobody ever really explained that to me. That's why they're arranged that way. But what's important is they're arranged in this way because of the number of protons they have, but that is also directly linked to the number of electrons they have. And the number of electrons an element has, particularly in its outer shells, which we're going to talk about, affects the reactivity of that chemical element. So, for example, if we look at helium, we know that helium is really unreactive. You can breathe it in and it doesn't really affect you, it affects your voice, but it's not having a chemical reaction in your body. The reason why helium is not very reactive is because helium has 2 protons, therefore it has 2 electrons. And if it has 2 electrons, we know that the inner electron shell only needs 2 electrons to be full. It's not looking to get rid of an electron or get any more. It's quite happy having a full electron shell, therefore it's fairly unreactive. Lithium, on the other hand, if we just add 1 more proton, we make lithium. Lithium has 3 protons, 3 neutrons, and clearly here has 3 electrons. So we know that the electrons in the first electron shell are quite happy. They're content. 2 is the maximum it can have, and it has 2. Unfortunately for lithium, or fortunately for us in terms of chemistry, the second electron shell only has 1 electron. And we know that the second electron shell can house 8 electrons. So lithium is actually highly reactive because it just wants to get rid of that electron and become stable with the inner electron shell. So it's trying to get rid of that electron as best it can, and that makes it a highly reactive substance. So when you look at these two atoms, the only difference here is one extra proton and one extra electron, but that changes the properties of that chemical quite substantially. Lithium, highly reactive; helium, almost unreactive. So what lithium is doing, what we're really concerned about here, is this electron here. And this electron here, the outermost electron, and any electron shell of any atom, the outermost electrons, we call them valence electrons. The valence electrons are the ones that are really interesting because they're the ones that are going to be involved in chemical reactions. So we're not too concerned about these ones. These two are fine in the inner shell because the inner shell can only hold two. What we're really interested in are these electrons on the outside of an atom, and we call them valence electrons. So valence electrons, there's a definition here. They are the electrons in the outer shell of an atom that are responsible for the chemical properties of the atom. Okay, so you may want to pause it and write that definition down. The electrons in the outer shell of an atom that is responsible for the chemical properties of an atom are valence electrons. Okay, I think that's enough for the first lesson back. If you guys want to come onto the Zoom, we'll go over this in more detail again, and I'm quite happy to come and have a chat with you guys and tell you what we're going to do for the rest of the term. Hamish, I thought I'd put Hamish in here because he's missing everybody. He says, always remember to brush your teeth. That is sound advice from Hamish. Thank you guys.